Hi, welcome to educators.com. I'm Shravanti, your Hadoop instructor. In this module, we are going to discuss about big built-in functions, mathematical functions, string functions, eval functions, and big custom UDF, mathematical functions. To find out the exponential, absolute, and floor, log, sine, cos, tan, square root, and we do have a lot of mathematical functions are available. These are all the built-in functions. If you wanted to use this particular mathematical functions, as I have shown you last time, if any of the function, if you wanted to use it with the row by row, you just need to put a for each generate, and there you can use any of the mathematical function as well. And here we do have string functions to find it out any of these, lowercase, uppercase, and some substrings, replaces, this regular expression extracts. With the help of some regular expressions, you can get some of the string information from particular characters. You can see the index of, and a lot of string functions are also available as part of this. And here, if you wanted to see these built-in functions, what we are talking about, let me show you. There is a very good documentation available on the built-in functions. So these eval functions are nothing but, especially it will read that record by records, and if you wanted to find it out like average, sum on all of these records, whatever the columns you are having it, if you wanted to use this count star, maximum, minimum, tokenize is nothing but it similarly works as your string tokenizer. We do have a different types of built-in functions are available. So let me show you by logging into our big built-in functions documentation, very clear documentation. And here, just open your browser, and as part of this, just enter big built-in functions. If you just enter the big built-in functions, it is going to show you all the documentation, or this big documentation in detailed documentation is available as part of the pig.apache.org. So if you click on this, you can clearly understand. See this, these are all the eval functions, and these are all the mathematical functions which are available, and these are all your string functions which are available. And if you wanted to see this, suppose I wanted to find out the average, so how I can use, just click on that. It will clearly give you an example as well. And if I come here and see this, what you need to do, first of all, if you wanted to perform anything, you just have to load the data set into your Hadoop distributed, this file has to be in the UDFs, and in the grunt shell, we are loading that into the pig shell. And now, if you wanted to find out the average based on specific column, first of all, you have to group by on that specific column, and then with the help of the for each generate, as I mentioned you can use the average, sum, max, min, such kind of functions you can execute with the help of this for each generates. In a similar way, if you wanted to concatenate two strings, see this, first of all, you have to load any of the data. Once the data is loaded, you have to apply this to the each and every record. So when I say that apply to the each and every record, you must need to use the for each generate. So concatenation of these two things, F2 and F3. Otherwise, you can also give the $1 and $2. Because this starts with the $0, you can give the $1 and $2 as well instead of F2, F3. The count is to know how many number of elements are available. Writing that specific bag, you can use that count and count stars, and here you will be having whether it is empty or not. A lot of built-in methods are available, so you can clearly see that what method you want to use, and you can come here and you can understand how to use. See this maximum, how to find out the maximum for each generate group of max of this. That means I'm using the maximum method. On top of there is a column called GPA. So in that GPA, we wanted to find out which one is having a more GPA. And similar way, if you wanted to use any of the mathematical functions, right? For example, I wanted to use a square root. Just see this square root. That means simply how you are using a marksman, like square root of which column you wanted to give a square root, you can just directly mention that. So it is quite easy. Similar way, string functions are available. Suppose I wanted to convert that into the lower case. So with the help of the lower of what exactly the string you wanted to give. Suppose $1. That means whatever the second column is there, I wanted to make it to the smaller case, the lower. So I can use that lower case. Alright. And these regular expressions, that is nothing but with the help of the dot stars, the normal regular expressions, how you will write, like star is nothing but multiple characters, like that you can even use. Similar way, we do have the substring. That means if you wanted to extract, have a big string, and from that I wanted to extract the first and third characters. I mean, whatever the content is there from the first index to the third index. All of these things I need to get. So in that case, you can use the substring method, substring function. Like that, you do have a different types of built-in methods are available, and you wanted to write your own custom UDF because these methods, whatever we are having it, this is not sufficing your need. Then what you have to do, you must need to write your own function. So how you are going to write your own function? We are going to see that by logging into our Cloudera Quick Start VM. So here, to write your pick custom UDFs, once after you verify all the built-in functions and you understand that you do not have any other built-in method to satisfy your requirement, then you decided to write your user-defined function. So you can write that as part of your Java, Ruby, and Python, or any other programming languages you can use. But mainly people will be writing the programs for the custom UDFs in the Java or Python. And here, as we have how we have written the MapReduce programs with the help of the Eclipse editor. Here also we can use that editor, and then we can write our custom UDF program. So this is also a class, right? Whenever I'm writing a class with the Java, so everything has to be a class. So first of all, it has to be override the exec. There is something called exec method. So you must need to override that particular definition of your exec. Now I'll show you by logging into the Cloudera Quick Start VM how to write your custom UDF. And once you have written your UDF, you need to export that into the jar file. And that particular jar file you must need to register from the picgarant shell. And then you will be writing your pig scripts to invoke this particular function. And now let me show you that. This is my Cloudera Quick Start VM, and here on top of your screen you do have Eclipse. Just double click on that. And here, this is my Cloudera Quick Start VM, and clicked on Eclipse. This was open. And if you see this training, and you will be having all of these default packages where we have written our previous programs. So what you need to do is, before writing any of the custom pig UDFs, what you have to do is you have to add the additional external jars. So right click on your project, click on build path, configured build path. So inside this configured build path, by default, a lot of libraries are there. And what you need to do is you need to add your external jars as well related to the pig. For that, just click on the add external jars, and then you can go to your if you wanted to go to your home, you can just click on the file system in the left hand side, go to user, lib, and then pig over here, because the pig has been installed in user lib pig directory. And here you have to add the external jar. So piggybank.jar is there, and you can even add these two jars, pig.jar and pig cdh 5.5.jar. These jars, the definition to write your pig custom UDFs, like it may be a exec function or overriding the definition of those methods, it is available there. So you just need to add these two things, or even you can even add this piggybank.jar. Piggybank.jar is not mandatory, but just add these 2 jars, or this one also, these 3 jars into that. Just click on OK. You observe user lib pig.jar and the pig version.jar and the piggybug.jar. That got also added into your build path, so that it will get add the additional information as well, so that it is easy to write your programs. And now what you need to do is, under the source, create a package, new Java package. Just give any of the package name called my package, for example. Right? You can just create any of the my package or my package one, any of these things, and click on finish. All right, so that my package gets created over here. See this? My package is here. Why we are creating the package is nothing but when we are exporting that into the jar file, we need not export everything. We can just export this particular package itself. So inside this package, now right click, new, and create a Java class. So you can write any of the Java class name based on your what kind of program you're going to write. For example, here, let's give it as a mypig UDF, for example. If you have written this something as a mypig UDFs, what it is going to do is a pig UDF, click on finish. You need not do anything, just give a name and click on finish. Automatically, so this mypig UDF class has been created, and here copy the content whatever I have given you in this attached video or else in this presentation. What exactly you need to do is, any of the pig custom UDF, you must need to extend the eval function, because here what I wanted to do as part of this is nothing but I wanted to read that entire record by record, and whatever is at the character at the 0th position. That is, suppose if I'm having a hello, what is the character at 0th position? This is H. In that H, I wanted to convert that into the uppercase. That is my criteria. So it has to read all the characters at the 0th position, and then it has to convert into the uppercase. So for that, it has to read a one by one record. So here what we are doing here is, we are extending the eval function and overriding the exec method. So how we are overriding the exec method over here is, alright, so here we call the data type. So we discussed as part of the custom data types, there is a tuple, bag, and atoms are the data types which we talk about. So the tuple is nothing but a record. So it takes the entire record by records. So here I consider that record as an input. So in this, what I'm going to do is, first I'm going to check whether any of the input size, if that input is having no records, then I'm just returning null. But if it is having any other records, then input.getOut 0, that is nothing but this, it's going to get the 0th positions 1. That means the first element it is going to retrieve from that tuple, and then it is going to convert into the string. The reason why we are converting to the string is nothing but, if it is a Java code which we are writing, right? So in the Java, if you wanted to use any of the caret of 0 or 2, then these are all the methods, Java methods, but I do not know any data type in the Java as tuple. So what you need to do, you have to convert the tuple data type into the string. That is the reason why, if you observe this particular line, what we are doing here is, first of all, we are taking that first element, and then we are converting that. Alright, we are converting that into the string. And now here, once you get that string, I'm going to first read the caret of 0th position, and then we are using the 2 uppercase. Alright, so with the help of that, what it does is, it just reads the character at 0th position is H, and it converts into the capital H. Alright, and so once we get this, as it is a character, when I say that why I have defined it as a character is nothing but, character is a single character, where in case of a string is a collection of characters. So now whatever the characters I got it, I'm just converting into the string to return that. Right, because if you see this method is expecting to return a string. That is the reason why we have converted that into the string back, and then we are returning that. So take any of the function. For example, you do have these converting your temperature from the Fahrenheit to the centigrades. In that also, if you wanted to do this, what you're going to do is read that. It's the same. You are going to extend the eval function and override it exec method, and you will be reading that particular input of get of 0 and convert into the string, and then write your code over here. Whatever the code you are writing to convert, whatever the formulas are, once you write this, you must need to return final result. You must need to return that. This is how you will be writing your any of these custom UDFs, and then just save it, and you need to export that into the jar file. Just right click and export Java jar file. Alright, export that into the jar file, give the jar file name. Let's call my jar file name as a pig UDF, for example. This is my jar file name. Just click on finish, done. It got stored directly as part of your desktop. If you see that, it directly stores over here. We have given it as a pig, right? So let's see where exactly our pig.jar is available. Otherwise, here just enter the complete path. Also, you can enter home cloudera pig udf.jar. Just save that and go here and do lsnc. You have to see your pig udf.jar, right? And now what you need to do is open your grunt shell just by logging into the pig, and now you have to register that particular jar file. Whatever the pig udf.jar, this pig udf.jar, whatever you created, you must need to register that, so that whatever the content is inside that, you can use that particular content. Ctrl L to clean the screen. So here, let's register that particular jar file. Okay, pig udf.jar does not exist. Let's see. Let's cross verify whether the name is correct. Capital P. Okay. It has to, it is the case sensitive, guys. So make sure that whatever the name you have given, it has to yes. Right? If you observe this, we have used the correct one, so it has been registered. And now to test this our methods, what we are doing here is we are just loading some sample. Yeah, this sample is not there. So what we do is let's create a sample file over here. Alright, how to create it? Just use gedit and just create a sample file. This sample file, let's assume this sample file can consisting of something like hello world and Hadoop, or else hello world. We are learning Hadoop. Right, we are learning Hadoop. For example, let's assume this is some sample file. So let's load this sample file into the HDFS, because if you wanted to use any of these things, you must need to load it, copy from local, and this is the sample file. I wanted to load it into the sample again, that is into the HDFS. File already exists, so let's call it as some sample HDFS. Always need to be a new file. Right, it is done. So some content is there, Hadoop fs cat sample HDFS. So what I'm going to do is I'm going to give this as an input, and whatever there as our function, what our user defined function is going to do is it is going to read it one by one, and it's going to take a character of 0th position and it will make it to the capitals. Right, I'll go back here, and now I will be giving that loading my sample HDFS. Okay, what is this? Unexpected 0th position. Let me see. You see here, load sample HDFS, and yes, it was loaded. If you wanted to see this, just jump So you can see the result. So now let's use our user defined function. If you see this, whatever the content is there, like hello world, we are learning Hadoop, it is there. So how to use our method is nothing but whatever the built-in custom UDF which we have created. So if I wanted to, as I wanted to execute this line by line, that means this record by record. So as I mentioned you, for each generate you must need to use whenever you are navigating across the record by record. So here, see this, for each generate, whatever is the A is the one which I have loaded my data set, and I'm just going here, and how I'm calling function, like earlier I used to call sum average directly, but here to call your function, you have created a package, right? So you have to give that package name dot the class, the Java class which you have created to write your pig method. Alright, so you have to give that this is the class name. My pig UDF is a class name, my package is a package name. This log ID is for the A, right? Whenever I have loaded this. See this? Earlier, whenever I loaded it, I call that as a log ID. So those are just a string, that is just a name. Alright, so this is how you can directly call your functions with the help of your package name dot your class names. So if you wanted to see the result, just dump that. You can see the result. So how exactly your package is going to be called over here is, as a first step, you have added that jar file with the help of the register command. So that is the reason why, as it is already registered, you can call that package name dot your method name, the class name especially, so that for each generate every record by record it goes and it displays the value. Now you can see the output as capital H and capital W, because the first character is hello world, H is 1, and the next one we do have something called we are learning, right? So it takes a W from there. And here, if you see the output, see here capital H and capital W. Like that, it may be any of this is a sample example, but whatever is your need, you can just directly write like this by extending this class and overriding these overriding your exec methods, then you can write your custom code. So summary, in this module we have seen how to verify your built-in functions, which are mathematical string and eval functions, and also we have seen that how to write your own custom UDFs in case if the built-in methods are not sufficient for your requirement. You can use Java, Python, any other programming languages to implement your custom UDFs. So once you write your UDF, export that into the jar and register that particular jar file, and you can directly call that particular method with the help of the package name dot class name. Before that, writing the program, just add that external jars, and then you can write by overriding the exec method. Thank you. Let's catch up in the next module.